Good morning, students. Today we discuss about some basic from Unit 4 of distributed systems. So this Unit 4 actually it deals with recovery and consensus. We'll see the basics. So here we are going to see about checkpointing and rollback recovery. So in that we'll see the basic concepts, then what is checkpoint, what do you mean by rollback propagation and uncoordinated checkpoint. So we'll see one by one. So rollback recovery protocols definitely going to restore the system back to a consistent state after a failure, because when we deal with a distributed environment, definitely there is a heavy chance for failure, right? So in that, how exactly we are going to recover to a consistent state, that's what we are going to think. We are going to discuss. It achieves fault tolerance by periodically saving the state of a process during the failure-free execution. Yeah. See, what we will do is basically, at some period we used to save. Even when we open a Word document and we are typing something, means we used to save. Suppose unexpectedly the system gets shut down or crashed me, what will happen? Whatever the last saved position, that from that only we can able to recover. Suppose unsaved content is there, means we can't able to recover back, isn't it? So similarly, here also periodically we are saving the state of the process, so that what will happen, whatever the last saved position, till we can able to recover. So it treats a distributed system application as a collection of processes that communicate over a network. So definitely with the help of checkpoint, we can able to do recovery. Now let's see what do you mean by checkpoints. The saved state is called a checkpoint, and the procedure of restarting from a previously checkpoint state is called rollback recovery. So a checkpoint can be saved on either the stable storage or the volatile storage. So usually, very basically, we can say that the saved state is called a checkpoint, because till that period, everything is checked and everything is worked well. So after that, whatever changes, if there is any failure occurrence, we have to start from the last saved point. So why is rollback recovery of distributed system complicated? Definitely, we are communicating in the distributed system with the help of message passing, right? So message-induced inter-process dependencies during failure-free operation is very tricky one. So rollback propagation. The dependencies among messages may force some of the process that did not fail to roll back. This phenomenon of cascaded rollback is called the domino effect. So actually what will happen when we are forcing to roll back the currently successfully running the process in order to do the recovery thing. So this concept is called as dominoes effect. And another one is uncoordinated checkpoint. In each process take its checkpoint independently, then the system cannot avoid the domino effect. So this scheme is called independent or uncoordinated checkpoint, because even when I am trying to check parallelly, another one system present in the environment is also trying to check the status, means what will happen. So it will create indirectly, it will create a condition and it will lead some errors. So what are the things we are so definitely we need to avoid this domino effect. So what are the possible techniques to avoid the domino effect? We have three possible techniques. One is coordinated checkpoint rollback recovery. Another one is communication induced checkpoint rollback recovery. And third one is log based rollback recovery. So we'll see one by one. So coordinated checkpoint rollback recovery. So here processes coordinate their checkpoints to form a system-wide consistent state. So definitely there should be a coordination among the processor who are doing the checkpoints. Maybe some 20 systems we need to check, means I will have a coordination stating that this 5 systems we can check, this 5 another 5 can check. Like that, it will be splitted among them, and the proper message via message communication, there is a proper coordination, so that we can easily avoid this domino effect. Next one is communication induced checkpointing rollback recovery. So forces each process to take checkpoints based on information piggybacked on the application. Yeah, definitely here also we are checking the checkpoint based on the available information and possible message communication happened in the network. Based on that, we are doing the checkpoints. The third one is log-based rollback recovery. It combines both checkpoint with the logging of non-deterministic events and relies on a piecewise deterministic assumption. Okay, so everything we are logging it, right? I mean, we are recording. I mean, we have a log-based system, so we know what exactly happened in the history. So based on that, we can able to do the recovery, that is log-based recovery. So these are the three techniques that is used to avoid the domino effect when we are dealing with the checkpoint and recovery. Then, before going into deeper, we have to see what do you mean by local checkpoint, consistent state, interaction with outside world, and type of messages. So definitely, when we create any algorithm, we need to have some basic assumptions like. So definitely here also we are having the assumption like we have fixed number of processes. These processes cooperate to execute a distributed application and interact with the outside world by receiving and sending input and output messages. We all know that in a distributed system, the communication happens with the help of message passing. That also we are assuming. And it uses the first in first out order. So whatever message comes first, it will be processed first. So these are the basic assumption we are having. And local checkpoint in the sense, all processes save their local states at certain instance of time. Like we will have some periodic, for example, in one case, we can have a periodic save, like every 5 minutes, the system state should be saved, or every 10 minutes, or every 1 hour, something like that we can fix. A local checkpoint is a snapshot of the state of the process at a given instance. At any instant, what is the current snapshot of the state of the process? That is called local checkpoint. And here also we are assuming that the process store all the local checkpoints on the stable storage so that we can able to recover, right? Whenever we need to read that, it won't get deleted. So we are storing it in the stable storage. The process is able to roll back to any of its existing local checkpoints. Okay, when it is in unsaved situation, it can go back to the last saved situation. That also we have to take care of it. Okay, then next one is consistent state. A global state of a distributed system is a collection of the individual states of all participating processes and the states of the communication channels. So here, when we talk about this consistent state, we have a consistent global state, a global state that may occur during a failure-free execution of distribution of distributed computation. If a process state reflects a message received, then the state of the corresponding sender must reflect the sending of the message. A global checkpoint is a set of local checkpoints, one from each process. A consistent global checkpoint is nothing but it's a global checkpoint such that no message is sent by a process after taking its local point that is received by another process before taking its checkpoint. Okay, then definitely the interaction with the outside world or within the process or in between process, everything happen with the help of message passing, right? So message communication is a very basic thing, and we have different types of messages, especially in transit message. That means message that have been sent but not yet received. So that message is called as in transit message. That is currently they are in transition. Then lost messages, messages whose send is done but receive is undone due to rollback. So that is lost messages. Delayed messages, messages whose receive is not recorded because the receiving process was either down or the message arrived after rollback. Then we can say that it is a delayed message. Then orphan message, messages with receive recorded but message sent not recorded. No, that is, we don't know the parent who sent the message. So urban messages do not arise with processes roll back to a consistent global state. And duplicate message. Finally, we have a duplicate message. It arises due to message logging and replaying during process recovery. So because of process recovery, we may broadcast the same message again. So it will automatically lead to the duplication of message. So these are the possible 5 messages like in transit message, lost message, delayed message, urban message, and duplicate message. So these are the basics, and with this we can use it with the help of a checkpoint, and we can able to do a proper recovery. That's all, and we have some basic algorithm related to this. We'll see in the next class. Thank you for listening.